I want to apologize about something, but I will leave that until the panel. And you can ask me why I'm apologizing now. But anyway, so hello. My name is Eduardo, and I want to start with your help. I know some of you are very introvert and will not want to participate, but just for 1 second, everybody raise your hands. All right. Thank you very much. Everyone, keep it up, keep it up. Only one hand, oh, sorry. Only one hand. Don't cheat. Yeah, thank you. All right. So if you are sure that, let's do the first bug. If you're sure that you can protect against XSS, you know what is XSS, Paris explained it, please lower your hand. All right. If you think you can protect against CSRF, you know what the CSRF team just talked about it, please lower your hand. No, I mean, only lower it if you know XSS and CSRF. So anyway. All right, anyway. What about mixed content? Lower it if you know about mixed content. OK, what about timing? Timing attacks in web applications? No? OK. Anyone knows about direct object reference bugs, like authorization bypasses, info leaks, and stuff like that? Hash extension bugs? OK, maybe let's do it backwards. Lower your hands. Anyone that knows how to do caching, use caching correctly for security purposes, like not put the wrong caching headers? Come on, one person. All right. Maybe there's someone in the other room, but as well. Yeah, maybe all of. If you are in the other room, no, I'm kidding. Don't do that. Anyway, so web security vulnerabilities are, well, quite a lot. Parisa just did almost the same thing I just did. He was asking like, oh, so tell me security vulnerabilities, and you were coming out with with plenty of them. Anyone didn't know about one of the vulnerabilities that she talked about, or that someone shouted? So every one of you knew all of the vulnerabilities that were mentioned. All right. So knowing how to prevent them, it's actually quite tricky. Not in all cases, it's trivial to know exactly what you have to do. So for XSS, you have to know about escaping, about the right order of escaping. We had bugs about there's the right type of escaping, but in the wrong order, and then you introduce a bug. For CSRF, there might be CSRF tokens sent, but then they are not enforced in one case, in like the one case that you need it. There is authentication bypass bugs, and they are just forgotten to add it in one place. Generally speaking, we have noticed, or we reached the conclusion, that even if you want to do things safe, even if you know about the bugs, it's very likely that you will introduce them anyway. We also noticed that even if you don't know, you are likely to introduce them. So it's, if you care about security, if you don't care about security, both ways you're going to introduce, in one case, very complex bugs, in the other case, very simple bugs. Maybe you don't know anything, you will introduce more bugs. But at the end of the day, you're going to have more than enough to have a non-safe web application. So as Parisa mentioned, I work in the product security team, in the product security response team. And what my team does is whenever someone finds a bug, like the ones that Team Willis just talked about, we go and work with the product team, and we work with them to make sure that it never happens again. So that means make sure that if a bug happened now, we try to look for similar bugs around it. We try to see what is the real root cause, and then we make it so that it doesn't happen. And as we tried to do this in the past couple years, we kind of concluded that we cannot trust humans. So humans are going to make mistakes. And we are all humans, so we all make mistakes. And developers have to be humans, because otherwise we have Terminator and stuff like that. So we came up with this, that what the developer has to know about security to be able to develop secure applications is what is in this slide. And that's, well, in these slides. And that's a white slide. And this is not all my slides, but this is the first slide. So if that's what a web developer has to know for security, then how can they develop secure web applications? How can we have secure web applications? So what we ended up doing is that we are now expecting that every security bug is the framework's fault. That means that if you're using a framework, and the framework doesn't prevent you from introducing XSS bugs, then the framework is not as complete as it should be, and then we should implement something in the framework that prevents the bug from being ever introduced. That's why the talk is called Vulnerabilities Should Not Compile, because it means that we should make possible that a CSRF bug can be launched into production. We should not make possible that an info leak or a directory reference or whatever should be launched into production. What this talk is going to be about is about several ways that we have been doing it in Google, or if we have been not doing it in Google, what we are planning to do in Google to prevent this type of security vulnerabilities. Don't consider that the things that we're going to talk about, that I'm going to talk about, not all of them are feasible for all web applications. So some of the things might not make sense for someone that is developing a game. Some of the things might not make sense for someone that is developing a bank application, for example, someone that has nothing to do with a specific subset of technologies. But still, the general principle is the same, roughly speaking. If I do my job right, then by the end of the talk, you will be able to eat, sleep, and code without having to think about patching a security bug. So you're going to be able to, if someone ever tells you, we have to patch this XSS, we have to patch this whatever, hopefully the first thought that will come to your mind will be, no, that's not how you fix these bugs. All right, let's see if this works. Nope. Oh, it worked. All right. So let's take one step back and figure out why we should even care about this. So why security is important? This is super fast, and I just want to mention it for 2 reasons. So because of your face, because of your reputation is in the line, because if you have a security bug and you are in the news, as Tim just mentioned, then it is your brand, your product, your website, the one that is being talked about. The second reason is your money. So if you are a marketing agency that is making business with another website, with another company, and that company gets hacked because of you, you are not going to get that business anymore. If they talk with each other, they're most likely not going to, you're going to have a bad name in overall. And the most important reason is because it's your responsibility. If you have users, your users trust you. And if your users trust you, you have some responsibility to them to be able to protect them against any type of vulnerability that you are meant to protect them. So I'm going to assume that, and so for the trust. So I'm going to assume that all of you want to do the right thing. All of you want to know how to do this correctly, that you want to protect the users, and so on. So the right question is, what is the right thing to do? I just told you what I think is the right thing to do, but let's see if that's really the case. So where does this box come from? So that's the right question, right? It's like where these vulnerabilities are coming from. Why do they exist in the first place? And the reason is, or at least the reason that we see, is because as services grow bigger and more complex. And by that I mean, at some point, you're going to have a website that is moderately successful, that is going to have several users or many users, and eventually, you're going to have more people that work on it, and it's not just you, now it's you and other people. Now, eventually, you're going to be talking with other services and other websites, and eventually, those other websites will want to talk to you in like some API, or you're going to be able to use APIs of other sites like, I don't know, Facebook or Twitter or Google Plus or whatever. And eventually, all of these becomes just a huge complex mess. So how do we look at complex systems? Like, I don't know, there is this very popular example of no one really knows where a pencil comes from. Like, it's very simple, but no one knows every single component, where it comes from, the pen, the lead, the eraser, and everything. What about an application like, I don't know, fancy.com? Like, do you guys think that there is one engineer in the company that knows how every single line of code, or that understands all the complexities around it, like the sandbox environments, all the third-party dependencies that they have? Maybe there's someone there is, but it's more likely there isn't. So the way that developers and anyone really can cope with this complexity is that they just simply, or we just simply see it as a simple process. So we just see it like, okay, this is what I expect to happen in this scenario, and we create a very specific set of schemas that or patterns in our brain of how things happen in the general sense. So we will be remembering like, oh yeah, so this probably works in this way, this probably works in this other way, and in some cases it works because the framework makes it work like that. In some other cases it doesn't work like that. So I'm going to go through 5 examples of when the assumptions and the way that you expect things to work don't work quite like that. And that's the reason where, that's the place where security vulnerabilities in most cases come from, when you expect things to work one way and actually they work a different way. So the first one is XSS. We talked about XSS a lot. HTML5, probably the most popular bug that any one of you are going to interact with is XSS. And this is an example of an XSS. So it's hello. This is PHP. I'm sorry about that. And it says hello, and then the variable name. And that's the user. And you as a developer, you as someone that is writing this code, expect that to write the user's name, not HTML. Like when you wrote this code, or whenever that person wrote this code, they literally did not expect that to be HTML, right? So the right question to ask is, why will it even be HTML? Like, why shouldn't it just be a string? Because that's what you expect, right? It's meant to, like, this syntax is meant to inject variables, not, I mean, it's meant to inject HTML as well, but like, in most cases, it's just going to be used to inject variables. All right, next example, authorization on CSRF. So this is a very simple request of a fake bank application. And the fake bank application, the only thing you want to do, the thing that you want this endpoint to do is like to transfer the amount from to that amount. And if it fails, then you send an error. If it doesn't fail, then you send a success response. So that sounds ideal. That will be the best type of code that you could ever write. It's like super simple, super compact. This post request, the only thing it does is call that API, and that's it. And that's the code that you write. That's the code that you want to write. That's the code that does what you actually want. You don't actually want to know about CSRF and how to generate these tokens and how to authenticate if the user is allowed to do this or that. Like, that's not really what this do post request is meant to do. This is just meant to do this one very simple thing, and you cannot do it like that. Another example, which is very similar to XSS in the source, in the reason where it comes from, is that you want to have a very simple SQL query that says select a star from product where SKU is equal to, and some interpolated string called SKU. And this is short and simple and readable. If anyone looks at the code, they know what this code is supposed to do. Unfortunately, that's vulnerable to SQL injection. Like if you just put a single code there, you can do whatever you want. But that's short, and that's simple, and that's readable, and that's vulnerable to SQL injection. And you just want to make things work nicely, right? There's two more other examples. One of them is authentication. And the case for authentication is a little bit tricky. So you have a login, and the only thing you want is the user to be able to, you just want to authenticate the user. You don't really want to do anything else. You just want to know who the user is. That's your goal when you usually do authentication. And the first thing that comes to mind to most people when they think authentication is a username and a password. That's normal, right? So then you have to deal with a Contra Covering. So you're going to do email or questions, or for enterprises, how an enterprise, how a company is going to recover their corporate account. Like if you have twitter.com/Google, for example, then how is Google going to recover that account? Like you cannot use secret questions because then an ex-employee can recover it. You cannot use an email because then the email can be changed. So how do you deal with those situations? Recovery abuse. So how do you deal with brute forcing? How do you deal with people brute forcing their way into an account? We all know Twitter has this problem that if you have a Twitter one-letter handle, everyone wants to get into that account. Hijacking, how do you deal with someone hijacks the account and then the real user wants to get it back? How do you deal with that? You have to deal with that some way. How do you deal with social engineering your own employees or social engineering the users into getting their account back? How do you deal with password reuse? How many times in the last year password databases have been leaked? So that has been, I don't know, Adobe, LinkedIn, several times. Monitor hijackings. You have to monitor whenever that happens. You're going to make something in there. You have to store your passwords in some strong salted KDF with maybe some key that is stored in HSM, and then you have to deal with performance and making sure that it happens correctly, and that if you lose the key and the HSM has a failure, you are able to recover gracefully without having to depend on the key being in the wrong place. How to deal with password managers. Like if you are going to enforce a minimum password strength, then how are you going to deal with that?
Excuse me, before you go on, I don't really know what was that?
You don't have to. That's the trick. So I'm not.
What if I want to?
We can follow up offline.
May I talk to you after?
Yeah, sure.
Appreciate that.
So there is more things because I said. Some users might want to know about two-factor authentication. Some people might want to detect suspicious actions and then block the accounts. Some people might want to be able to deal with cross-device authentication, how to deal with a password in a phone and then in a website. Weak passwords, how do you, yeah, I think I mentioned this briefly before. You're going to enforce a minimum strength. If you're going to protect against brute forcing, online brute forcing, putting a CAPTCHA is not going to be enough, of course, because then people that want to get into an account are going to want to have a CAPTCHA. Are you going to put a strength meter? If you're going to put a strength meter, how are you going to measure the strength? And I don't want to continue. There is one more thing, third-party libraries. And this is not all the things regarding security. These are just 5 things that I happened to choose because this diagram had 5 balls, and I wanted to put 5 things. So for third-party libraries, you have to read all the documentation and looking for all dangerous functionality and unsafe configurations. So if you're going to be using an XML parser, you have to know about XML external entities and about billion laugh attacks and stuff like that. You have to know about if your video player is doing, is downloading codecs. If it's, sorry about that. If your SVG does foreign resolution of objects, and then that allows itself to load another XML file within your SVG file and then load some internal resource in your page. Or DOM.js, for example, that was nice. That some people were using DOM.js, which is a node thing to load scripts from other page, and that ended up causing remote code execution because that's how it works. You also have to monitor CVEs and changelogs and announce lists to be able to know whenever the thing has a security bug. You have to adopt and deploy and fix. You have to, once the server goes out of life, how are you going to deal with that? And if the new versions are not compatible anymore, if they have an API change, what are you going to do? So all of these things seem super complicated, and you just want to do a simple thing. You just wanted to have a website that shows videos to their friends. And then you have to have some video converters, and then you have to deal with authentication, and then XSS and authorization, CSRF, and SQL injection. And how do you deal with that? So what is the right thing? Let's come back. What is the right thing? So the right thing is a blender. So this is not a framework, before anyone thinks I'm selling you a framework. The reason I mention a blender is because this is an example of something that all of you know, I hope, and that has something very special about it. So it is a machine that has a motor that turns like super fast and very strongly, about 500 revolutions per second, and has a super sharp blade on it, and that can destroy bones and do all sorts of scary things. And somehow we were able to put it in such a form that is relatively safe to use under reasonable and non-so-reasonable circumstances. So just to share a story, my wife was telling me that she put a spoon inside one of these blenders, and it was OK. And I was like, yeah, that's right. It should be OK. So the blender has several security mechanisms to prevent them from being a problem, even if they are misused. If there is a warning in the manual that says, do not, under circumstances, turn the knob 3 times and then press the button 5 times, because in that situation, then the blade is going to go out spinning and hit you in the eye. Like that's not how it works, but except that that's how it works for several web frameworks and platforms. Like, oh yeah, by the way, you shouldn't do this in this way, because if you do it, then that's obviously vulnerable, duh. So yeah, a blender is meant to be safe against someone that has seen someone use it once and can continue to use it without having to care exactly about how it works. It knows what is dangerous. It knows there's a blade. It knows not to put its hands inside. And if you put your hand inside, I looked online. Most people recover their hands. Anyway, we shouldn't go there. So maybe the right thing to do is to let developers do what they need, and then just fix these problems in the frameworks themselves. And I'm going to explain very quickly what this means. So for example, for XSS, if a user has a template like this, and user ID is a string, then it needs to be URL sanitized first, and URL escaped, and then HTML escaped. That's obviously right. That's obvious, right? But the framework can know this. The framework knows that the user is about to write something into that specific place. It knows that this one only requires HTML escaping. It knows what to escape in what order in what case. The framework knows. It knows the context. It knows the HTML. So it can just do it, right? In this case, if name is string, it requires HTML escaping. But what if name is allowed to be HTML? How do you deal with that? Well, then you can do something like safe HTML, like a new type that is not just a string. It's a string that has a special meaning and that is special for allowing itself to be rendered as HTML. And the framework can recognize that, oh, this is marked as safe HTML. Let's render it as safe HTML rather than a string. The framework knows that. And a developer that is writing code that is putting this code that it is, OK, this is safe HTML, will be safe. At the worst case scenario, you might end up not escaping something, but then you're going to notice that it's not escaped correctly, and you're going to fix it. You're not going to have a security bug. This case is a little bit more complicated. So Google Analytics, for example, gives you a script tag that you have to put in your website. So this is very similar to what I mentioned before. So if you have to put a specific type of script tag, then the templating system can detect that this is an HTML snippet, and then it's going to inject it like that. And then the developer doesn't really have to think about this, right? They just have to mark the things that are meant to be HTML as HTML, and if they are not HTML, they are going to be rendered safely. So it works. So you can store the safe HTML as safe in databases. You can do whatever you want. You can make sure that your apps are protected against XSS by default. And this works for client-side applications and for server-side applications. Another example is authorization checks. So you have like 4 different endpoints, web endpoints. And you want these web endpoints to all have authorization checks. And what you have to do, usually, not always, but what you usually have to do, is you have to put different authorization checks in different places. So where should you put it? Should you put it in here, or here, or here, or all of them, or in the top 4? I think the answer is pretty obvious, that you probably want to put it as close as possible to the data. This is called usually row-level security, row-level authorization. And if you put it this way, it's more likely, it's only one place that you have to do the security. You have to program any security ACL checks. And if you do it right only once, then you're safe. If you do it wrong in any of these 4 places, then you are not safe. These are things frameworks can help you with. Authentication, there are 2 ways of doing authentication. Federated identity, if you trust your users to have one of these 4 accounts, or any of the other ones, using OpenID Connect or whatever. Or you can do your own. Maybe the framework should provide something to allow you to do it by yourself. And they should be able to manage all the questions that I asked before. Or if you don't want to do it yourself, which is a reasonable thing to do, to not do it yourself, then you can just trust one of the federated identity providers to do it for you. Libraries is the last one, and I think it's interesting. So if you have a service that you trusted to take a screenshot of a website, the only thing you want it to do is to go take a screenshot and then give you the data back. However, whenever you load a third-party library, it has this ambient authority of access to everything. So it runs as you. It can read usually all your source code. It can read your keys and connect to your databases. It can do whatever it wants. If you sandbox it, then the only thing it can do is connect through HTTP to this service, get the data that it needs back, render it, take a screenshot, and then send you back the screenshot as an image. Same thing for decompression functions. The decompression functions don't need access to the internet. It just needs access to one directory. It reads the directory. It reads the compressed file. It outputs it in another directory, and then it gives you back to you. You can even do this for encryption and key management. You can say, like, OK, you have access to this. The only thing you have access to is to this specific key store. Whenever someone accesses the key store, it leaves a log, and then you can decrypt the data. If someone finds a bug in any of these things, then they only get access to one thing, right? They only get access to take more screenshots, whatever. They only get access to decompressing more files. It's like decompress away. So yeah. Now, bear with me for a second. That's a fun. So imagine that you can write secure code. You can write secure web applications without having to think about security in general. that you trust your framework to do everything for you. Now, you might think that I'm going crazy because there's no framework that does this for you. And you will be kind of right. So what we're doing, and we are doing it starting today, is that I want you, by the end of this talk, to think about the last security bug that you had to deal with. It might be an XSS, it might be a CSRF, it might be whatever. And I want you to send an email to your framework, to whatever framework you used. And I want you to tell them that they should fix it, that they are responsible for fixing it. And if you want to go one step ahead, you can actually write the code that does it, and then send them the code. Or you probably want to discuss with them first and figure out what's the right way. But they might tell you that they have bandwidth, or they might be an open source project that runs on volunteers, in which case you can write the code for them. And if you do that, then Google will give a reward amount from $500 to $10,000 to you and or the framework maintainers if they help you push it to code. So we're announcing this for a couple of web applications. I don't remember the name of all of them, so I had to write them down. So the ones are Angular, Clojure, and Dart, and Git and Go, which are from Google. And then the Django, all the projects from the Dojo Foundation, which are the Dojo Toolkit, Require.js, Grunt, Lodash, Embed.js, etc. Ember, Jinja, Worksec, and Flask, jQuery, Knockout, Struts, and Wicket. And we're happy to add more if you tell me which one I'm missing. Tell me if you want to learn more, just go g.co/security-patch-rewards, and that will give you more information.
It'll have that list. It'll have that list.
It has that list and way more.
Terrific, because I can't write that fast. And I won't remember it.
All right.
Thank you.
No problem. So if you do that, you will be able to help yourself to write simple and secure code. You will be able to help millions of other developers to write simple and secure code. And you will make everyone happy, and you will make yourself happy. And to finish this presentation, I just want to say that it works. We did this for Google in a couple cases, for several types of vulnerabilities, for XSS, for example, and it worked. Some of the products that were in the top vulnerable went to have 0 bugs in a couple years once they finished the migration. And that's it. Thank you very much.